welcome to this webinar, How to Future-Proof Your Infrastructure as Power Demands Grow. This event, brought to you by Mission Critical, is sponsored by Eaton. I'm your moderator, Amy Al-Khatib, editor of Mission Critical. Thank you for joining us. Today's presenter is Joe Scorian, Business Development Manager with Eaton. Joe has over 20 years experience in applications engineering and product development in the power distribution and data center markets. He holds a degree in electronic technology from St. Paul College and a bachelor's degree in management information systems from Dakota State University. He has been named on several U.S. patents. In his current role with Eaton, Joe is responsible for power distribution solutions for IT and enterprise data center applications. Don't forget to submit your questions, and later in the program, our presenter Joe will address as many as possible. Today's event is being recorded and archived on www.missioncriticalmagazine.com/webinars. And now I'm excited to turn it over to today's presenter, Joe Scorian.
All right, thanks a lot for that great introduction. I want to thank everybody for joining today. Got a decent amount of information to go through, but we should have plenty of time at the end for any sort of questions that come up, so I encourage you to please ask those throughout the presentation. Just a quick overview of what we'll cover today. We're going to talk about recommendations for simplifying distribution in and out of the enclosure. We're going to talk about how to effectively manage and secure cabling. We'll discuss the benefits of bringing color into the white space. And then at the end, we're going to talk a little bit about how you know if it's time to upgrade, considerations around density, connectivity, sensors, and monitoring considerations. First of all, to set the stage, I think it's important to kind of get to the heart of what we're talking about here, which is power is in a support role to data and compute in the data center. It's no secret we live in a connected world. Everybody's aware on a daily basis. We're glued to our devices. We use our devices to communicate with people. We use our devices to collaborate. We use our devices to buy things online, watch videos, stream music. This little pinwheel here is kind of an interesting chart, and it gives you a breakdown of what happens in an internet 60 seconds. So it kind of shows you from a transactional and data standpoint what happens every 60 seconds on the internet. When you look at the data here, it's truly mind-boggling what's going on within a minute, let alone an hour, a day, or a year. And really at the heart of that, the key is as data expands, so does compute and power requirements. So we're being tasked in a data center to support that. And from a power standpoint, you have to have the power to deliver and support that equipment. We're going to start off with just a little polling question, just to kind of level set how important power is in the data center. So can anyone or can everyone answer this polling question? How much energy do you think U.S. data centers consume annually? So the choices are 30 billion kilowatt hours, 60 billion kilowatt hours, or 90 billion kilowatt hours. There's no wrong answer. There is a wrong answer, but this is really just to get an idea of how aware people are of the current situation. I'll give everybody a couple of minutes to respond here and kind of fill your answers in. All right, looks like we're starting to fill in here with responses. Again, how much do you think U.S. data centers consume annually? All right. Okay, I'm going to go ahead and go to the results page here. All right, so we've got just a few of you that think it's 30 billion kilowatt hours. More of you think it's 60 billion kilowatt hours, and the majority think it's 90 billion kilowatt hours. All right, those of you who guessed 90 billion kilowatt hours are correct. So kind of a large number, and so this is just U.S. data centers. When you look at this from a global perspective, global data centers use roughly 416 terawatts of power per year, which works out to roughly 3% of the total global energy electricity consumption. So just kind of an interesting factoid here. It's 40% more than the entire United Kingdom. is how much power data centers use. And this, there's no signs of this letting up, right? With the increased amount of data and compute, this is expected to double every 4 years. Thankfully, there's a lot of solutions out there to help offset some of this. A lot of data centers are employing renewables, solar, and other things. But still, it just kind of sets the stage for how truly mind-boggling the amount of power required is in these data centers. But ultimately, the effect of this on a data center's power infrastructure, this increased IT equipment power consumption means new methods are required to optimize PUE. So you're continually looking for ways to increase that efficiency in the data center. On top of that, this higher density equipment means more cabling challenges. So as you get more compute into the rack, you have to get more data in and out of the rack, which means either more dense connectors or more cables and connectors coming in and out of the rack. And then, of course, from a power perspective, every time you have more power, that also translates to more heat. Power translates to heat. So you start to push the limits of air cooling, and that's why we see more and more recently people are talking about liquid cooling as a solution to some of these problems. So liquid cooling could be something as simple as like a heat exchanger door on a cabinet. It could be on-shift cooling, or could even be immersion cooling, which is starting to gain some traction in certain high-density environments. So really, it's important that we develop application-specific distribution. So it really requires understanding the needs of the environment. The fundamentally first thing you need to do is clarify rack power consumption. So a lot of times people refer to that in the rack as what's my KW, the KW of the rack. You'll hear that very often, and that's really just when you add up all the power draw of all the equipment in the rack, what's the KW rating of all the equipment that goes into the rack. And then from there, you can kind of back down to the appropriate type of power, appropriate type of connectors, et cetera. Next thing you need to do is you need to refine your distribution strategy. So that's looking at how is the power going to get out to the racks of equipment. So very common today, you'll see overhead distribution via a busway type system. So that's where you have a busway running with power drops that drop over the enclosures. But you also still see RPP and more of the traditional underfloor. So where you have like a raised floor and you run your power underfloor from an RPP or a PDU. And so those whips would come up underneath the floor. So it's kind of a difference between does the power come overhead or underfloor, and then how does it connect into the PDU once it gets inside the enclosure. So that brings you to the decision on a PDU of how does the PDU sit in the rack? Does it sit with the cable coming out the top, the cable coming out the bottom? And do you want the power cord coming out the face of the PDU or the end of the PDU? So that kind of comes into physical constraints within the rack enclosure and how that PDU best fits into the rack. And then the next thing you want to look at is cable length. You don't want a situation where you have a lot of excess cabling. If you have, whether it be on top of the rack or underfloor, you don't want rolls or bundles of cable sitting there. The more you have there, the more it obstructs airflow. The more the more clutter in the way, the harder it is to work in the environment. So ideally, you want to keep those cable lengths sufficient to reach where you need to get to, but without extra that it creates some sort of excess. And the final thing you want to look at is securing the IT outlet connection. So that's when you plug that server or that storage or router plug into an outlet. You want to keep that plug from falling out, either by an accidental bumping or even just through common vibration. So you want to look at either some sort of a grip or a locking type solution at the outlet level. The next thing is you want to effectively manage and secure cabling. So, this can be data cabling and power cabling. Looking at the photograph here, that's a very nicely, what I would call a nicely dressed data cabling cabinet, where everything's cable tied nicely. The bundles are held very straight. By keeping everything cleanly routed like that, it makes it easier when there is a problem to try to trace down some sort of trouble. The other thing that it does is it keeps airflow, facilitates airflow easier because you're not having such a mess of cables. You have spots where the air can kind of transfer through. Something that can really help with this is purchasing wider and deeper enclosures. I don't think anyone ever said they purchased too big of a rack enclosure, but I've heard plenty of people say later on, gosh, I wish I would have gone taller. wider or deeper to fit either cabling or even to fit things like PDUs, which or even to fit servers nowadays, which can sometimes hang very deep into an enclosure. Some things you can do from a PDU perspective to help with this are alternate mounting capability. So a PDU, traditionally, you're going to mount either two on one side of the rack or maybe one on each side. But there's also options where you can mount the PDU 90 degrees so the outlets face the back. So the idea is to try to pull those PDU into a wide stance and get them out of the way of the equipment. And there's a few different ways to do that, but that's something you want to consider early on in the design process. Okay, we're going to move to our next polling question here, which is, have you used color in the white space? So this question is basically just meant to be, have you used color to denote something in the white space? Kind of leaving it open at this point. Any way you brought color in that maybe has helped you. Looks like we've got some responses coming in already. I know that's kind of a strange question, right? Have you used color in the white space? It's a white space by name, I guess. All right, we'll just give a couple more minutes for more responses to come in here. Looks like we got a little bit of a neck and neck race here. I'm going to give it just another minute to give everybody a chance to answer, because we've got pretty even results coming in at this point. All right, go ahead and move to the results screen here. So you can see here from responses, there's a majority of people that have used color in the white space, but still a pretty significant percentage that have not looked at any sort of color in the white space as far as, denoting something. So I'm going to talk a little bit about why we believe color in the white space has a lot of value. We started seeing a few years ago customers bringing color into the white space to denote things as simple as like an A and a B power feed. So in a traditional data center, you're going to have two power sources coming in to feed the equipment. And one of the common risks that exists is you've got two power feeds, but how do you know that your dual input server, you plug one cord into each, into each power feed? Obviously, when you plug it in, you're going to be very conscious of that. But if the cables are all black, everything looks the same, you can imagine it'd be very easily to accidentally connect something incorrectly, and all of a sudden you have both your power feeds off the same source, which obviously if you lost your A or your B source, you could lose power to that equipment. So what we've seen more and more is customers are moving towards color coding their A and their B power feed. What we see most often is red and blue as the color code that people are picking. We've also seen white and black as kind of a common choice. And we've even seen companies go with like company or brand colors, or maybe team colors if you're a sports team. So it's a way to bring a little bit of, kind of personality into the data center, but also serves a very, very utilitarian purpose in identifying your A or your B feed. And you can see that photograph in the background there that has some pictures of different PDUs that have color coding, a lot of different colors there, as you can see. Pink, maybe Mary Kay data center, or, a little bit of yellow and green for the Packers, maybe, if there's any Packers fans out there. But you can see just a lot of different choices and a lot of flexibility in how you can color code things. Another way you can use color is denoting phases and or branch circuits on a PDU. So within a PDU, like especially a three-phase PDU, you're going to have different circuits coming out, coming in. You're going to have three phases, different branch circuits, and you want to make sure that when you're balancing your load and plugging things in, that you're plugging it into different phases and different branch circuits. You'll notice on this PDU, next to each one of the outlets, there's a different color next to each one of the outlets. And so you'll see the yellow, the blue, and the red, and then it repeats itself. And then so when you're plugging things in, you can get that alternating phase connection as you go down the strip. And it's just a way to visually help prevent overloading or misloading a PDU. Another way that we use color is on PDUs that are managed. So where you have the capability to turn outlets on and off. That LED light next to the outlet will tell you if the outlet is on or off. It'll also tell you through either a different color or through blinking, it will tell you if there's an overcurrent or an under voltage situation. So that light can actually draw you directly to a problem at the outlet level and tell you that there's something wrong there. Then the other thing to look at is not only on the plugging into the PDU itself, but also coming in, power cable coming into the PDU, marking that somehow with color that matches the PDU and the power cable color. So a lot of times that'll be putting color-coded electrical tape at all of your connectors. So for example, on your busway, you'll have on the cable end of the connector, you'll have maybe a little bit of red tape, and then on the PDU, you'll have some corresponding red tape. So when you're making those connections, you know red, red, blue, blue, very visual and easy to identify what you're connecting to in a situation like that. All right, so next, I'm going to talk a little bit about how important performance is in a data center. Just an analogy here, the Mercedes-Benz AMG has around 300 sensors on each high-performance car. The data is used to optimize performance during and after a race to improve performance. So you might be wondering, what does a race car have to do with a data center or have to do with power? When you think about it, data centers are very much like a race car, right? They're continually being tasked to perform, to improve performance, to run faster operations, and at the same time trying to do it efficiently. And just like a race car engine, heat is a major challenge. You're continually battling that. As the performance increases, so does that heat, and so you need to keep it cooled and you need to keep it efficient. And really that's how a data center very much ties into any sort of performance device out there on the market. So modern PDU are continually logging over 100 data points per PDU. Now that may seem like a lot of data points, but when you take into account there's all the outlets, there's voltage, current, power, and so all this data is being logged by the PDU. That information is used to generate alerts. So you could get like an alarm that tells you maybe there's an overcurrent on an outlet section. So that would be something that would immediately tell you there's a problem. But on a normal operating basis, that data is actually just being fed into a system that's logging and monitoring. So that would be like a software package that's doing monitoring of all the data that's being fed. And that data is being analyzed by that software to analyze performance, to potentially make recommendations. It can be used later on when you have a problem and you want to try to look back and understand what went wrong. You can look at that historical data in software. You can use software to help with load balancing, so you can see if your two sources are loaded properly. You can use software to do a failover analysis, so you can say, let's simulate what happens if we lose A power feed and it fails over to B power feed. What would happen in the data center? Would we lose power to our equipment, or would everything be just fine? And those simulations are critical to ensure that you're preventing a problem before it happens, rather than reacting to something after the fact. RecPDU have extremely high accuracy monitoring. You can track power consumption to within 1% of actual power, which gives you billing grade capability. So there are, for example, co-location data centers who will use a PDU to bill customers or track power usage for customers, or sometimes that's used internally for department billing or kind of allocating power out to different groups within a company. Outlet switching gives you the capability to reboot locked up servers, turn unused outlets on and off. So again, this is really meant to be a time saver and to get ahead of problems and to resolve problems quickly. So instead of having to go out onto the floor, figure out what's happening, you can remotely control things, remotely turn things off. Now, on top of just power monitoring, you can connect external sensors. So you can do things like temperature monitoring, humidity, smoke, water, door contact closure. So door contact closure would tell you if someone's entered the rack, if they've actually opened and closed that door. So all of these environmental sensors give you awareness into the rack environment and tell you what's happening. So if something's happening and you need to take action, you want to find out before, say there's some sort of water or smoke problem, you want to find out before that causes the entire rack or even a section of the data center to go down. So getting that heads up information allows you to take action. So really all this ties into management software that's going to be capable of alerting you of these potential problems, again, before they end in some sort of downtime. So one thing we like to talk to people about is making sure that you're replicating your power footprint across your infrastructure. So it's no secret that today's data networks are super complex. It used to be that people who manage network closets, on-premise data centers, co-location data centers, often they worked in silos, right? Different groups within a company, you weren't always coordinating with each other, deploying different standards, having maybe a different power approach in different locations. But what we see now more is power management has become the core of the infrastructure. So people are deploying a common platform and aggregating in common management software across the entire infrastructure, so you can get that kind of single pane view of what's happening in all of your locations, rather than just in one specific location. Really, at the end of the day, the reason people have gone this direction is it simplifies deployment, and more importantly, it simplifies management to be able to look at all the devices together and know everything is operating fine. Got another poll question here, which is, how costly is downtime? You could all please answer this question just in your own opinion, or I guess maybe answer how, what answer matches best to your own facility or your own data center, if your company's done any sort of studies on this. We actually have, as Eaton being in the power business, we've done a fair amount of, customer surveys and other things to try to understand how important and how expensive downtime is for customers. Looks like we've got some answers coming in here, and so far it's fairly evenly split across the three. We'll give it a couple more minutes for everyone to be able to answer the survey question. This, I would say, there's no right or wrong answer. There's a survey answer, but of course, everyone has their different value that they place on their infrastructure. Some, partly depends on what you're doing at your data center, of course. All right, so the survey results came in, and it looks like the most popular answer was $471,000, and the Eaton survey says you are correct, $471,000 per hour, which, when I first saw this, I kind of questioned the results on this, but, when you look at what a lot of data centers are processing from a business continuity standpoint, the transactions, whether it be something in the banking industry or whether it be some sort of retail, and you roll it up across all the locations, it truly makes sense, the value of downtime per hour. So interestingly, some people surveyed, about a quarter of the people surveyed said it could exceed $1 million per hour. So just talking a little bit about the benefits of optimizing power distribution within high density environments. Of course, first and foremost, you can reduce the risk of unplanned outages. So when you take these extra steps, it just helps prevent problems from occurring, and that's why people go to all these steps on the front end. You can decrease your overall energy consumption and reduce cooling costs. Of course, cooling costs are going to be your largest expense in most data centers, so anything you can do to reduce those costs is very important. And then most importantly, you want to try to identify problems prior to these outages occurring. So I talked a little bit about that before, trying to get ahead of problems, solve problems before they result in downtime. And that's really the end goal, is to do more predictive analysis and get ahead of things rather than just waiting until something goes wrong and then trying to deal with the aftermath from it. So taking this a step further, even just preventing, power downtime, there's other threats that can cause problems in a data center. One thing that's very heavy on people's minds in the last couple of years is cybersecurity threats, right? So there's continually people trying to intrude into data networks, and it's a big problem for people. We see that same problem on power devices, and we've gone to a lot of great lengths over the last couple of years to work on testing our network cards for intrusion testing, rolling out policies and procedures for deploying the network cards to reduce risk of intrusion. So cybersecurity guides, best practice guides, ongoing testing with software. So as new threats are coming out, we're trying to stay ahead of new threats that are hitting the market. Obviously, if somebody could get into a power device, in a worst case scenario, they might be able to actually even shut power down to something. So it's a very very serious threat that could exist out there. The next thing you want to look at is just the physical infrastructure itself. So the rack enclosure. A lot of threats actually come from within. So it's not always that that dark character hiding in the basement somewhere. A lot of times, an employee within a company could be up to something, could be up to some no good, or could accidentally even be causing some sort of a problem. So deploying things like electronic door locks, monitoring the doors with door sensors to know when people have been in and out of the rack, deploying security cameras in your, in your spaces so you can see what's happening. Those are all steps that you want to take to secure the physical environment. And then, of course, we talked a little bit before about the environment itself as far as temperature, humidity, seismic sensors. These are all things to help further on, kind of keep an eye on the environment, make sure that nothing is happening. All right, so just take a closer look at a typical PDU and roll up how all these features that I talked about might tie together and what a PDU actually looks like. So we talked a little bit about, from an input standpoint, the ability to be able to configure different power inputs. So having that cable come out the front of the PDU or the end of the PDU, having different cable lengths. So maybe if the power is really, really close to the rack, you want a 3-foot cord. Maybe if it's overhead power and your busway is up higher on the ceiling, you need something closer to 6 or 10 feet to reach up. So having the cord right size is important. We talked a little bit about phase balancing, so having alternating phase outlets that are color coded. So as you go up and down that PDU, you want to move between phases and branch circuits, so you can help load balance everything. So this keeps your devices evenly balanced across all your circuit breakers and evenly balanced across all your phases. From an outlet standpoint, having outlet grips, so that's to keep your plugs from accidentally falling out or getting bumped out of your receptacle, is very important. The capability to do things like remote monitoring and remote outlet switching. So the more you can do remotely in that environment, it's going to save you time and money of people physically at the site. But more importantly, you're able to react to problems faster by being able to do things remotely. Some of these data centers are large, maybe even physically hard to get to remote locations, or maybe the people you're sending to those locations aren't ideal to be working in the racks. So being able to do more remotely just simplifies that whole process. Looking at the capability to be able to configure different power inputs. So there's a variety of different kW ratings that a rack may be deployed in. So you want to have the capability to be flexible with your kW ratings, which would translate to your plug types, your voltage types, your current types that are coming into your PDU. Having your communication port be a secure communication port that you can do monitoring through to be able to get ahead and prevent problems. We talked about the importance of color coding. So things like on a PDU having a color coded chassis. So having the side of the chassis painted with different colors, having the network card different colors, so that as you deploy your A and your B feed, it's very easy to tell which power source it is. And then another important factor is what kind of outlets you might need to have in the PDU. So making sure the quantity of outlets, the type of outlets, matches up with the quantity and type of equipment that's being deployed in your data center. All right, so that summarizes that ends my presentation for today, but I wanted to open up to any questions that people might have.
Thank you, Joe, for a great presentation. We'll address some of the questions that have been submitted throughout the program, but if you have a question for Joe, please submit it in the Q&A and chat tab. Our first question is, how accurate are the failover simulations?
The failover simulations are based on the assumption that if your A and your B goes away, that the combined total of the A and the B is your power consumption on either A or B. I would say it's fairly accurate, but it's not going to be exact. I would say it's better than the current method today, which is a lot of hoping. For most people, they generally just kind of plan it on paper and hope for the best, where this actually uses real numbers to give you the data.
Okay. Next we have, do rack PDUs have a short circuit current rating?
They do. Every rack PDU is, well, let me rephrase that. The protection devices used inside a PDU are going to have a rating. So that would be the circuit breakers or the fuses inside a PDU. PDUs as a device, the way that they're UL tested, they're actually UL approved as a piece of IT equipment. So from that standpoint, the device itself doesn't have a short current rating, but the circuit protectors inside there do. So when you're planning in a data center, you're going to calculate your, different points throughout your data center, what your estimated fault currents are. And when you get to the PDU, you're going to want to make sure the circuit breakers are sized accordingly for that. So just from an Eaton perspective, we offer different levels. 5,000 amp interrupt is kind of the industry standard that if people don't tell you what it is, that's generally what it is because it meets the minimum UL spec. But then we also have high fault current ratings, 10,000 amp, and even 100,000 amp fuses that are optional for extremely high fault current type situations.
Great. What is the best way to compute PUE?
There's actually 3 different ways to compute PUE. That they refer to it as level 1, level 2, and level 3. So just from a best practices standpoint, we recommend level 3 PUE calculations, which actually uses the readings that are taken at the outlet level. So in our managed PDU or our metered outlet PDU, you can read the power consumption at the outlet level by the IT equipment. So basically, PUE is looking at the IT equipment versus the total power consumed in a data center. So in a perfect situation, right, all the power consumed in a data center will go directly to the IT equipment. But we all know that in the real world, you've got cooling and other building overhead that's associated. So that's what the difference. That's what PUE basically shows you is what the difference is between the IT load and the overall facility load.
Thank you for that explanation. We have another question. What about an RPP system that provides DC power to racks instead of AC?
There's some of that going on today when you look at what some of the players in the hyperscale space are doing. So when you look at what Facebook has done, through the Open Compute program, Google is doing some of that with basically DC that's actually being generated at the rack and then distributed out to the equipment. There's been a lot of research into looking at DC in the data centers and how it increases efficiency. But I would just say that in the U.S. today, it's not quite ready for prime time. Minus people who are deploying in very large scale, it's not quite there. But it's definitely an ongoing area that I expect in the coming years you're going to keep seeing more about that for sure.
Okay. Can a PDU be configured with a convenience outlet for portable test equipment in addition to the normal rack-based outlet?
Yeah, we do that in some of our PDUs. Like what we usually refer to that like on a 3-phase PDU, we might have a 120 volt outlet, and then all of the other outlets are 208 volts. For like the servers and devices. And the 120 volt outlet is meant to power things like maybe you need to recharge a laptop or maybe you need to use some piece of equipment that doesn't run at 208. So we generally have that when it's available. The only challenge can be sometimes if it's strictly a 208 volt or higher voltage, like even a 400 to 230 volt environment, you can't easily get that lower voltage. So in those cases, we wouldn't offer that.
Okay. We have a few more questions here. What should I consider first when designing a data center? The power density, the technology needed, or what needs to be powered?
You really need to start with what needs to be powered and kind of start backing it up from there. So I guess I would say when you talk about the technology as far as how you monitor or control things, that's kind of like a separate decision from how much power you need and how many devices you're monitoring. So no matter what your power density, your kW at the rack, you can get different PDU technologies in that same kW rating. So you need to start with what's going to go into the rack, how many devices is it, what kind of connectors do they use, and then you need to add up the total power consumption. And generally what people like to do is put a little bit of headroom in there and kind of plan for the unknown. Of course, plans never change last minute, right? So, that's, it happens time and time again, right? Where all of a sudden you thought you were going to do one thing and something else came up. So generally planning a little extra power is not a bad idea in a data center.
Okay. What software do you use for monitoring or managing the PDU?
So, so Eaton PDU are compatible with really any third-party power management software or SNMP-based monitoring tools. Eaton has software called VPM and VCOM, which is VPM is basically built specifically for monitoring power, so it's purpose-built for monitoring PDUs, UPSs, and then VCOM is more kind of gets into things like asset tracking and kind of more of your traditional DSIM type solutions. But really our general rule of thumb is we like to work with any management software because we realize that people have maybe already deployed something, but if they haven't or if it's not doing what we need it to do, Eaton has solutions that work, are tightly integrated with our hardware too.
Okay, we had sort of a comment and a question following up from someone related to that. They said that connectivity and monitoring makes sense, but I was wondering, are there ways that PDU can actually reduce admin costs?
Yeah, so probably the number one way that they do that is the remote aspect of being able to control power. And we have a lot of customers who have been doing upgrades, especially when you look at like when you have multiple locations. Think of like a bank or a medical facility where you've got a lot of different locations. You've got edge locations where you're deploying equipment, and you don't have IT staff at all these locations, and yet you still need to sometimes turn things off, reboot things. You want to still keep an eye on the environment, make sure everything's okay without having to be there regularly. So in that way, it kind of gives you eyes and ears remotely. But even more so in data centers, even like in our own Eaton data center, for example, very, very sparsely staffed as far as the number of people who are on site. And even at that, we have redundant data centers, so there's not even people necessarily at both sites all the time. So having eyes and ears into the data center reduces lets you do more with less, basically, is the best way to put it.
Great. Before we move on to the next couple questions here, I just wanted to remind everyone that we do still have some time. So if you have any questions that you'd like to get answered, you can submit them, and we might be able to get a chance to ask them to Joe still. So I will move on to the next one. One of the attendees said he has had issues with plugs falling out of outlets, and he's wondering, what do you recommend to deal with that issue?
Right. So that kind of goes back to like I was talking about with a grip, with some sort of a grip or a locking type outlet. So as far as what Eaton's done to resolve that, our standard IEC type outlet has a grip built into it that grabs onto the plug, and that keeps it from falling out or getting bumped out. It can still be pulled out in an emergency, but it doesn't just, it's not going to just bump out if somebody's working in the rack, for example. We've also integrated locking plug capability. So there are some plugs out there that have little locking tabs built into them, and so we also support that kind of plug. You have to buy those cables separately, so there's an added expense, but sometimes people are getting color-coded power cords anyway, so it's not a big deal to just get the locking cords at the same time. So those are the solutions we have. I mean, there's some other vendors have different locking solutions of their own too that they've deployed.
Okay, and then unless we get a couple more questions coming in here, the last one we have right now is, what recommendations do you have for dealing with high rack temperatures?
So if you have high rack temperature, you have to start off by looking at things like how you're handling the airflow in the rack. That's probably the first thing we always recommend. So sometimes we've seen scenarios where people have maybe like a chimney containment, and maybe there's too much hot air building in the back and they can't get it out fast enough. So doing some sort of hot aisle or cold aisle containment, keeping keeping the cool air supply and the hot air supply separated. That's kind of like a fundamental thing that actually is amazingly successful in solving problems like that. If you still persist with problems, or especially if you're deploying like higher kW ratings in particular, you might need to look at things like a liquid cooled rear door. People have had really great success with that kind of a solution. I generally don't tell people. I know I've seen people who have just added supplemental like in-row cooling but a lot of times that extra cooling doesn't necessarily solve the problem because you just have so much heat coming out the back that adding cooling in the front doesn't necessarily fix every problem. But that is another solution that people deploy if they have trouble getting the cold air to all the racks. Sometimes you can add in-row supplemental cooling or other solutions like that.
Great advice. We had a couple more questions come in. What do you see as the leading DCIM solution in the market, and what new DCIM capabilities do you see evolving?
So what I would say the leading solution is Eaton's VCOM software. Of course, I'm probably biased, right, because it's an Eaton solution. But what I like about the software is it basically has all the typical, high-level features that you'd have with DCIM type software, but it also adds basically a visual overview of the data center, and more importantly, it's tied in very nicely with with power distribution, where a lot of DCIM software power distribution is kind of an afterthought. But typically, when you're dealing with someone managing the white space, power distribution and what's happening at the rack levels is extremely important. So I think it's a mistake to overlook PDU, the importance of PDU in that software interface. And so it kind of ties into things I talked about, like being able to do failover analysis, being able to look at your load balancing between your phases, and doing those types of things that gives you, preventative type of tools. So in my mind, software is better if it stops a problem from happening rather than just reporting that a problem happened after the fact. Like, it's great that you found out that half your data center powered down, but it sure would have been better if you would have known that was going to happen before it happened, right? So that's the end goal of software like that.
Okay, and then what is the current lead time for your PDUs?
So Eaton has a variety of stock solutions. So I would say a lot of our stuff ships right out of inventory. But if you get into our configurable products, like our higher density and the configurable models, in smaller quantities, we shoot for a 3-week lead time as our standard. And then as you add quantity, it kind of goes up from there. Obviously 3 weeks has a limit to the quantity, but for anything in that 25 to 50 piece order range, we're usually out the door in 3 weeks.
Okay. Well, it looks like that's all the questions we have today. Please join me in thanking Joe Scorion for his presentation, as well as our sponsor, Eaton. If you have any additional questions or comments, please don't hesitate to click the Email Us button on the console. As you exit today's webinar, please take a couple minutes to complete our survey. We strongly welcome your detailed comments. Please visit www.missioncriticalmagazine.com/webinars for the archive of this presentation, as well as information about our upcoming events. We appreciate your time and hope you have found this webinar to be a valuable experience.